Hello everybody, Mr. Wallace here. It's time to learn about some exponents. So we are going to learn about 5 exponent rules today, and I'm going to break it down for you bit by bit. But first, we need to remember what an exponent is. Let me just adjust the focus real quick. Okay, so an exponent. Vocabulary, we have the base here, and it's being raised to a certain power. That's the exponent part. And then, of course, we know the meaning of an exponent is how much the base is multiplied by itself. The exponent tells us that. So now we can just multiply all these through and find our final answer. So knowing that, we're going to apply it to algebra. Our first example is, what if we multiplied x to the third, or x cubed, by x to the fourth power? Well, I'm going to use the definition of the exponent and expand each of these and see what's left. So I'm going to take x cubed, and I know that is x times itself 3 times. That's one group. I'm going to multiply it by the other group, x to the fourth power. That's x multiplied by itself 4 times. And what you should see overall is that we have x multiplied by itself a total of 7 times here. So this actually ends up being x to the 7th power. Another one we can try, x squared times y squared times x. So we're going to expand all of these exponents, write them out. X squared is x times itself. Y squared is y times itself. And then we just have x. What we can do is group all the x's together, and we're going to have 3 x's multiplied by each other, so that's x cubed. And we have 2 y's multiplied by each other, that's y squared. So our final answer is x cubed, y squared. But the thing is, we don't have to write this out every time. We don't have to show all of these steps. We can use this rule to help us out, and that is called the product rule. So this is something you need to take down your notes. What you can actually do is just end up adding the powers together. So like when I had x to the third times x to the fourth, that's the same as x to the 3 plus 4 power, x to the 7th. So that's going to save us a lot of time. Next, let's look at if I multiply. Or let's look at if I divide, the opposite of multiplying. X to the 5th divided by x squared. I'm going to write that out in expanded form. I know that x to the 5th is x times itself 5 times. And x squared is just x times x. So now it looks like I have 5 x's multiplied by itself in the numerator and 2 in the denominator. Now we can cancel these out just like we cancel out factors with fractions. So 1 for 1. 1x on top gets canceled out by 1x on the bottom. Next, another x can get canceled out by the other x on the bottom. And now we've reached the point where we can't go any further. We just have 3 x's multiplied by each other. That is going to be x cubed. Next, x to the 7th power divided by 3x squared. We have x multiplied by itself 7 times here. And then 3x squared is 3 times x squared, so that's by 2 x's. And now, knowing that we have the same factors in the numerator and the denominator, we can start canceling them out. So an x on top and an x on bottom cancel, an x on top and x on bottom cancel. So finally, we're just left with 5 x's multiplied by each other on the top and a 3 on the bottom. So that's going to be x to the 5th power over 3. Now we don't have to write these steps out all the time. Here's our shortcut. Next is the quotient rule. So as long as these are the same base, they have the same matching variable, when they're divided by each other, you can take the exponent in the numerator and subtract away the exponent in the denominator and get your final answer. Okay, next, what if we raise an exponent to an exponent? For instance, x squared to the 3rd power. X squared to the 3rd power, let's write that in the expanded form. That's just x squared multiplied by itself 3 times. And then we can further divide or further expand all of these. Each x squared is x times x. So we have x times x times x times x times x times x. So at the end of this, we end up having 6 x's multiplied by each other, and that gives you x to the 6th power. And that's our answer. Next, 2y cubed, all of that raised to the 2nd power. Now, since we have a coefficient here and a variable, both of those components are being raised to the 2nd power. They're both being squared. So we need to distribute this squared to both of those. So that's going to be 2 squared times, well, still y cubed squared. So make sure that the coefficient gets attention. It gets the exponent as well if it's included in the parentheses. So that's going to be 2 squared is 4, y cubed squared. That is y cubed times y cubed. And then we have 4 times y times y times y. That's y cubed broken up. And then another y cubed expanded out. You can see that we have a 4 and then 6 y's multiplied by each other. That works out to be 4y to the 6th power. And that's your answer. This rule can be simplified. We don't have to show out all that work writing all those y's out. The power rule simplifies it for us. So actually, when you raise an exponent to another exponent, you can just multiply the exponents together to get your final answer. Okay, now I'm going to show you something with negative exponents. So if we have something like a to the negative 3rd, the problem is that is not what mathematicians consider correct. they don't consider it proper. They follow the rule of no exponents in the answer, no negative exponents in the answer. So it turns out, in order to get rid of this negative in the exponent, you have to turn this numerator into a denominator. You actually take the inverse of it. It's going to be equal to 1 over a to the third power. So that's how you resolve a negative exponent. Now we have a negative exponent in the denominator. In order to make this y to the negative 2 power positive, you have to make it switch its place. It's going to inverse, and since it's from the denominator, it's going to go into the numerator. And now we have just y squared. This is what's called the negative exponent rule. So you can either go from the numerator where it's negative to the denominator where it's positive, or from a negative exponent in the denominator turns into a positive exponent in the numerator. So we need to have all of our answers showing only positive exponents. Lastly, we just have one more rule left. It's the easiest of them all. It is the zero exponent rule. The zero exponent rule states that any number or any variable raised to the zero power is equal to 1. So it doesn't matter what the base is. If the base is x or y, anything raised to the power of 0 is 1. Even if it's 157 to the 0 power, that's still 1. If it's a million to the 0 power, it's still 1. Anything raised to the 0 power is 1. That's your bottom line here. Okay, so those are the 5 basic rules of exponents. But let's talk about what happens when we have a big problem to deal with. We have multiple steps going on. Well, when we have multiple components going on, we have to follow order of operations. And the way that works with these exponents is the following. It's sort of related to PEMDAS, but basically the first step you should take, or the zero step you should take, is if you have any freebies, whenever you see anything raised to the 0 power, you know it's equal to 1. So that can simplify some things up front. Next, you should be looking for any exponents raised to exponents. You should use the power rule next, because the power rule is like an exponent raised to an exponent, that is e in PEMDAS. Lastly, all 3 of these are of equal importance. They're like the multiplying and dividing of PEMDAS. The product rule, the quotient rule, and the negative exponent rule can all be applied at the same time in whichever order you want. Just like multiplication and division, you're reading left to right and doing whatever appears first. So let's look at an example like that. If we have the quantity of negative 2a squared b, all raised to the second power, and multiply that by 7a cubed times b, we would have to figure it out. Now the first step is to look for any power rules. I see an exponent that's raised to another exponent. So we're going to distribute this squared to each term inside of the parentheses, the coefficient and each variable. So that's going to give me negative 2 squared. Make sure that negative 2 is in parentheses. It's negative 2 times itself. Then we have a squared squared and b squared. The second part's remaining unchanged for now. So now I'm going to use these exponents here and simplify them out. I know -2 times itself is +4. A squared to the second power, that's the same as a to the 2 times 2, or a to the fourth power. B squared, and then 7a cubed b. Now we're ready to start using the product rule or quotient rule. There's only the product rule that I see here. I see ones with the same base, and I can combine them. And a to the fourth power times a to the third power will give you a to the seventh power. That's a multiplied by itself 7 times. We can also do the coefficients. 4 times 7 is 28. And lastly, the b's. B squared times b, well, there's nothing written here, but you can assume that's b to the first. So that's going to be b to the 2 plus 1 power, b cubed. And that is our final answer. Next, we have a division problem involved. I also see some negative exponents, so let's see what to do here. I don't see anything with the zero exponents, but I do see a power raised to a power. So we need to resolve that first. This squared is going to apply to the 4, to the x cubed, and to the y to the -1. So let's rewrite that as 4 squared, x cubed squared, and y to the -1 squared. The denominator has remained unchanged so far. So now I'm just going to simplify these out. 4 squared is 16. X cubed to the second power, that is the power rule, so multiply those exponents together. X to the sixth. And then again, -1 times +2, that's y to the -2nd power. Okay, now we can start canceling things out, but I would recommend that we get rid of any negative exponents. I prefer to eliminate the negative exponents and rewrite them as positive ones as soon as possible. So y to the -2nd in the numerator is the same thing as a y squared in the denominator. So 16x to the 6th over 2x squared y squared times another y squared. So now we have all positive exponents. That's looking good. And now it's just time to clean up and see what else we can eliminate with the variables. What can we simplify? Well, first I'm just going to look at the coefficients. A 16 and a 2. 16 over 2 is 8. So we keep an 8 in the numerator. Looking at my x's, I have an x to the 6th on top and x squared on the bottom. That is your quotient rule. So that is x to the 6th minus 2. That is x to the 4th power. And lastly, we have y squared times y squared in the denominator. So that's the product rule, but the y's will stay in the denominator. So that is going to be y to the 2 plus 2 power, y to the 4th. So our final answer is 8 times x to the 4th divided by y to the 4th. All right, I hope you found this review useful, and good luck.